Hi all, this class is about frequency measurement. So, first one is the mechanical technique, how the frequency is measured from mechanical technique. So, it is based on slaughter line method, which is an indirect method. The standing wave set up in a transmission line or a waveguide that produce minima for every half wavelength apart. So, it's having signal generator with variable attenuator and a frequency meter, and slaughter line is splitted into two parts. One is connected with crystal detector probe and it is reaching a SW indicator directly, and the next section is from slaughter line is connected with the crystal detector mount and it is directly connected with matched termination, and the other end is connected with standing wave ratio indicator. So this minima or detector and the distance between them is measured, from which the wavelength and the frequency can be calculated by lambda g equal to 2d minimum. So f equal to c by lambda naught, and this lambda naught is equal to lambda g into lambda c and divided by root of lambda square g plus lambda square c. So here lambda naught is the free space wavelength and lambda c cutoff wavelength and lambda g guide wavelength. D minimum can be measured by the slaughter line probe carriage. So first one is direct method. The most commonly used type of microwave frequency meter is wave meters. It consists of a cylindrical or coaxial resonant cavity. The size of the cavity can be altered by adjustable plunger. So the cavity is designed in such a way that for a given position of the buncher, so the cavity is resonant only at one frequency in the specified range. So the wave meter in the direct method diagram is given here. So the cavity is coupled to the waveguide through an iris in the narrow wall of the waveguide. If the frequency of the wave passing through the waveguide is different from the resonant frequency of the cavity, the transmission is not affected. So if these two frequencies coincide, then the wave passing through the waveguide is attenuated due to power loss. It will be indicated as a dip in the meter. So from the electronic technique, the first method is counter method. An accurate measurement of microwave frequency can be measured here. The input signal is divided into two equal signals by a resistive power divider. These two parts of the signal are fed to two mixers. The mixer 1 is used in the input phase locked loop and the mixer 2 is used to determine the harmonic number. The frequency F1 of the input PLL is also fed to the direct counter circuits. The input PLL consists of a voltage controlled oscillator, mixer, an IF amplifier and a phase detector and a gain control block. The VCO searches over its range until an IF signal equals to 20 MHz is found. Phase lock occurs when the phase detector output sets the VCO frequency F1 such that by mixing IF2 with IF1 and rejecting 20 MHz and higher frequencies, NF0 is obtained. So counting the number of zero crossing for the period F0 determines the harmonic number of N of the phase lock loop. So the input frequency is then calculated by presetting into IF reference counter, measuring F1 and extending gate time according to number N. And the technique is explained with this diagram. So here in the frequency in the measurement unit, it's having the one power divider and it is split into two, mixer 1 and mixer 2, and mixer 1 is connected with IF amplifier and phase detector, and mixer 2 is also connected with one IF amplifier and mixer. So in the output from the voltage controlled oscillator and FTU output is connected with mixer 2, and both will be reached the gain control system, and phase detector output is given to the gain controlled system. So the frequency is measured by using this direct and indirect method and slaughter line method.